In the world of computing, the color green is more than just a stylistic choice. It is a legacy. If we look back at early computer monitors, the reason is straightforward. These monochrome displays utilized a zinc silicate phosphor, known as P1. When energized, it emitted a signature bright green glow. These screens became the face of the digital revolution, creating an association between technology and the color green that survives to this day. However, when we turn our attention to the printed circuit board, or PCB, the explanation becomes far more intricate. It is a story involving chemistry, human biology, military standards, and the sheer momentum of industrial tradition. The anatomy of a board, it is a common misconception that the board itself is green. In reality, a standard PCB is typically constructed from phenolic paper blend of wood fibers and phenol formaldehyde resin. This base material actually ranges in color from a pale tan to a deep butterscotch brown. The manufacturing process begins by bonding a thin layer of copper to this substrate. A pattern of circuit traces is then applied using a protective mask, and the board is dipped into a chemical etching solution. This acid eats away the exposed copper, leaving behind the intricate pathways that carry electricity. In older electronics, components were attached by drilling holes and soldering pins. But modern boards use surface mount technology, which is faster and allows for components to be placed on both sides of the board. The rise of the solder mask as electronics shrank and circuits became denser. Manufacturers faced a crisis. Thin copper traces were fragile, prone to oxidation, and easy to damage during soldering. To solve this, the industry introduced a protective coating in the late 1970s called a solder mask. This resin layer is what actually provides the iconic green color. The mask is applied using silkscreen techniques, covering everything except the specific points where components need to be soldered. Once exposed to UV light, it hardens, protecting the traces from corrosion and preventing solder bridges, accidental connections that cause short circuits. Why green specifically? While solder masks can technically be any color, often uses black, and prototypes are frequently red dark green remains the global standard. There are several practical reasons for this. Human vision and inspection. In the early days, every board was inspected by hand. Scientists found that the human eye is most sensitive to green, allowing inspectors to spot tiny defects with less eye strain. It provided the highest contrast against the copper traces compared to red or blue pigments. Military requirements. During the Cold War, U.S. military conducted studies concluding that white text on a green background was the most legible combination under varying light. Since the military was the largest buyer of electronics, manufacturers standardized green to keep them happy. Technical superiority. Green solder masks actually perform better. Research shows that green resin can produce solder dams as small as 0.1 millimeters. Other colors like red or blue struggle to reach that level of precision, often limited to 0.12 millimeters or higher. Manufacturing efficiency. Switching colors is a logistical nightmare. It requires shutting down the assembly line, cleaning out the machines, and wasting expensive resin. Since most circuit boards are hidden inside a casing where the user never sees them, there is very little incentive for companies to pay extra for a different color. The future of the status quo. Today, even though machines have replaced human inspectors, the green and white high contrast combo remains the most efficient for optical scanning systems. There is also a chemical advantage. Green pigments use insulating elements like chlorine and bromine, whereas black or blue pigments often use carbon or cobalt, which can be slightly conductive and lead to interference. In the end, the dominance of the green circuit board is a classic case of if it ain't broke, don't fix it. It is a perfect blend of accidental history and optimized engineering that has become the literal backbone of our modern world.